Lesson 2. We talked about Faraday's law, Lenz's law, inductance. This was the inductor's lesson. This was our first lesson having to do with inductance, mutual inductance, and circuit parameters. Okay, Faraday's law states that the voltage induced in a coil by a reaction of a magnetic field is directly proportional to the rate of change in flux and the number of turns, and inversely proportional to the change in time. This is n times change in flux over change in time. This is on your formula sheet. Okay. That there is on your formula sheet. Okay, know that Lenz's law says that an induced voltage always opposes its source. All right, and then we get into how to calculate inductance. And inductance, I believe this is the formula that's on your formula sheet. Yes? This last one here. Okay, and then this is how we get there. Okay, all of this says here, this whole slide says that an inductor opposes a change in current. An inductor opposes a change in current. An inductor stores current, right? We learned that one in the time constant stuff. Okay, mutual inductance. When two coils are brought into close proximity of each other, such that the lines of flux from one cuts the turns of the other, they are said to be mutually coupled. This is our transformer lesson, right? Where two coils electrically isolated, one can induce a voltage in the other just with the lines of magnetic flux. All right, this is on your formula sheet. Mutual inductance equals our coefficient of coupling, which is right here, times the square root of L times L1 times L2. We'll only give you two inductors to figure this one out. Okay, and we have to give you either M or K. Okay, so we give you K, and you've got to find, two inductors in series, 80. You've got to get M and then find total inductance. Okay, in series with no mutual inductance, it's just like resistors in series. We just add them up. Okay, 80 total inductance, L1 plus L2 plus twice mutual inductance. Opposing, L1 plus L2 minus 2 times mutual inductance. So make sure you know these because you are going to get clean formula sheets tomorrow. Okay, make sure you know this. Okay, this was without mutual inductance in series. We just add them up, and now 1.6 millihenries opposing. We got 3.2 millihenries. When we multiply it by 2, it's opposing, so we subtract from 40, and to get 36.8 millihenries. Okay, in parallel with no mutual inductance, it's the reciprocated sum of reciprocals, just like we do resistors in parallel, or product over sum if you have two branches. Parallel with mutual, 80. Again, if it's 80, it's going to be more inductance. The way I always remember it, smaller denominator, right? Notice that the numerators are the same. 80, it's going to be a smaller denominator, so L total is going to be bigger. And opposing, bigger denominator, which means L total is going to be smaller. Is everybody good with parallel mutual? All right. Your product over sum, or the reciprocated sum of reciprocals, is 9.375 millihenries. This is 80, so it's going to be minus the 2m in the denominator. Any questions?